Good morning, students. Today our lesson is about reflections with the coordinate plane. And this is a continuation of the previous lesson. Our objective is to reflect shapes in all four quadrants using coordinates. Now let me quickly refresh your memory on coordinate plane. Now a coordinate plane is a two-dimensional plane formed by intersection of the vertical line called the y-axis and the horizontal line called the x-axis. So the intersection of the x-axis and the y-axis is called the coordinate plane. We have the x-axis as the horizontal line, and we also have the y-axis as the vertical line. So to write your coordinates, we write it this way: x comma y. The x coordinate comes before the y coordinate. So in this lesson, we will concentrate on three types of reflections in the coordinate plane. So we have reflections across the x-axis, we have reflection across the y-axis, and we also have reflection across the line y equals x. Just like what we talked about in the previous video, the vertical reflection, horizontal reflection, this is similar to that. So we have a rule for reflection, as I mentioned earlier, which we're going to discuss now. So when you're reflecting across the x-axis, the x coordinate remains the same while you multiply the y coordinate by -1, meaning that the x coordinate remains the same and you negate the y coordinate. Now, when you reflect across the y-axis, the y coordinate remains the same while you multiply the x coordinate by -1, or simply put, you negate the x coordinate. And when you reflect across the line y equals x, this is what happens. You switch the coordinates. So y comes in place of x and x goes in place of y. Let's talk about the first one, reflection across the x-axis. Now, to reflect a point across the x-axis, the x coordinate remains the same and the y coordinate is negated, meaning that the y coordinate is multiplied by -1. As you would see, the reflection of xy across the x-axis is x comma -y. This is what I mean. Now look at this. The coordinate is 2 comma 4, and when you reflect across the x-axis, you have it to be 2 comma -4. The x coordinate remains the same, 2, while the y coordinate is negated, meaning that it is multiplied by -1. Here's the next one. Reflection in the y-axis. To reflect a point across the y-axis, the y coordinate remains the same and the x coordinate is negated, meaning that the x coordinate is multiplied by -1. Now take a look at it. Now if you reflect this point a -3 comma 2 across the y-axis, this is what happens. The y coordinate remains the same. You can see that 2, while you negate the x coordinate, meaning that you multiply the x coordinates by -1. So if you have it as negative before, it turns to positive. If you have it as positive before, it turns to negative. The third type of reflection is the reflection across the line y equals x. Now to reflect a point across the line y equals x, all you simply need to do is to switch the coordinates. You switch the x coordinates and y coordinates. So the reflection of x comma y is y comma x. All you need to do is to change the places. Here's an example. You have a point 2 comma 5. When you reflect this across the line y equals x, you have it to be 5 comma 2. And that is what you have displayed on the graph. Now let's take a look at this. Write out the coordinates of the vertices of this triangle. Now in this triangle, we have three vertices. So you can decide to label them A, B, and C. So the x-axis, you have it, that's the horizontal line, and you have the y-axis to be the vertical line. Remember that the x-coordinate comes before the y-coordinate. So the first coordinate, which is A, is 4, 5. When x is 4, y is 5. The second coordinate is when x is 1, y is 2. That's 1, 2. And the third coordinate, when x is 4, y is 2. So this is what you have. The coordinates of the vertices of the triangle are given. A 4, 5, B 1, 2, C 4, 2. So you can decide to label your triangle so you have letters for each of them. Okay? Example 1. Reflect the triangle with vertices in the x-axis. So they want us to reflect the triangle across the x-axis. Okay? So the first thing you need to do is to write out the coordinates of the vertices of the triangle given. So I'm going to start with the first coordinate. So at this point, remember the rule, the x coordinate comes before the y coordinate. So when x is -2, y is -4. The second coordinate, when x is -5, y is -1. And the third coordinate, when x is -2, y is -1. So this is what we have. So the coordinates of the vertices of the triangle are shown there. So you can label each of the vertices and you have this. Now we have a rule for reflecting across the x-axis. The x coordinate remains the same and the y coordinate is multiplied by -1. So to reflect across the x-axis, we write out the coordinate of the reflection, which is the image, and that will give us the following. If you take a look at it, you discover or you notice that all the x coordinates for the reflected image are the same as the object. Okay, however, the y coordinate is multiplied by -1, or the y coordinate is negated. Now, when you're done getting the coordinate of the reflection, which is that of the image, now you can go on to graph the image. That's -2, 4, -5, 1, and -2, 1. So here's the image. So when you reflect this triangle over the mirror line, you have that. Okay? Example 2. Reflect the triangle with vertices in the y-axis. So the first thing you need to do is to write out the coordinates of the vertices of the triangle. Okay? The first point is 4, 5, 4, 1, and 1, 1. Now remember the rules. When you're reflecting across the y-axis, the y coordinate remains the same while you multiply the x coordinate by -1. So that will give you the coordinates of the reflection. Now, when you're done getting this, you need to graph the image. So you have -4, 5, -4, 1, and -1, 1. So this is what you have. Example 3. How do we reflect across the line y equals x? Now you're given the coordinates of the vertices of the object to be this. Remember the rules when you're reflecting across the line y equals x. You simply switch the coordinates. So x goes in place of y and y goes in place of x. So the coordinates of the vertices of the image will be this. So just switch -4, -2 for the object, then the image will be -2, -4, and the same for B and C. So when you graph the image and the object, you have this. You have negative 4, comma negative 2 for point A, negative 2, comma 0 for point B, negative 5, comma 1 for point C. Those are the three vertices. And for the image as well, you have the same thing on the other side. Example 4. Write down the coordinates of the vertices of triangle P. Now, if you take a look at triangle P, you have three vertices. So you can label it A, B, and C. And these are the coordinates of the vertices of triangle P: 1, 4, 4, 2, and 1, 2. The next question says reflect P in the x-axis. Label the new triangle Q. Remember the rules: to reflect P in the x-axis, the x coordinate remains the same while you multiply the y coordinate by -1. So that will give you 1, 4, 4, 2, and 1, 2. The next question says reflect Q in the y-axis and label the new triangle R. Now, when you reflect Q in the y-axis, remember the rules. The y coordinate remains the same while you multiply the x coordinate by -1. So you would get -1, 4, -4, 2, and -1, 2. When you're done finding or writing down the coordinates of the vertices of triangle Q and R, you can go ahead to graph the image. As you can see, triangle Q and triangle R on the graph. That's the image. So triangle P is reflected in the x-axis to give triangle Q, and triangle Q is reflected in the y-axis to give triangle R. So here's a quick summary. When the mirror line is the x-axis, we change each x, y into x, -y, meaning that the x coordinate remains the same while the y coordinate is being negated. When the mirror line is the y-axis, we change each x, y into negative x, y. The y coordinate remains the same and the x coordinate is negated. And finally, when you reflect a point across the line y equals x, the x coordinate and the y coordinate change places. So we switch the x coordinate and the y coordinate. So if you have x, y, it's going to change into y, x. For example, if you have 2, 4, it's going to change into 4, 2. And that is what you have shown on the graph for the different reflections across the x-axis, across the y-axis, and across the line y equals x. Thank you for listening and have a good day.